Hello, my dear students. Welcome to SHLOKA'S Academy. In this video, we are going to discuss how to balance a redox reaction. Balancing of redox reactions. Before going to this topic, we should know some basic terms and rules. Any equation that has to be balanced may be given in form of an ionic equation as well as formula unit equation. So, one should thus know how to convert a formula unit equation to an ionic equation and vice versa. Let me explain how to convert a formula unit equation to an ionic equation. For this, I am taking a formula unit equation in aqueous medium, that is 10 moles of FeSO4 plus 2 moles of KMnO4 and 8 moles of H2SO4. 8 moles of H2SO4 to give 5 moles of Fe2SO4 taken twice plus 2 moles of MnSO4 plus 1 mole of K2SO4 and 8 moles of water. So this is a formula unit equation, and here we go how to convert this formula unit equation into an ionic equation. So for that, I will teach step by step. Listen carefully. The first step, let me consider left-hand side. Let me consider at left-hand side, that is reactant side. Here we have 10 moles of FeSO4 and 2 moles of KMnO4 and 8 moles of H2SO4. FeSO4 can be written as Fe plus 2 and SO4 minus 2. Whatever the stoichiometric coefficient that has, so that has to be written as it is. In that, no change. That means here you have to write 10, and as well as here also you have to write 10. Now, KMnO4 can be written as K plus and MnO4 minus. So how many moles was there? 2 moles. So you can write as it is here, no change in stoichiometric coefficient. And H2SO4 can be written as 2H plus and SO4 minus 2. So how many moles were there? 8 moles. So here also you write same 8 moles. This is all about reactants. We have converted all the formula units into ionic forms. In the same way, let us do at right hand side, that is product side also. In the product side, we have Fe2SO4 taken twice, which can be written as Fe plus 3 and SO4 minus 2. This is 2 Fe and this is 3 SO4. And what was the stoichiometric coefficient for this? 5. You write 5 as it is. And MnSO4 can be written as Mn plus 2 and SO4 minus 2. And what was the stoichiometric coefficient? 2. And here also 2. K2SO4 can be written as 2K plus and SO4 minus 2. Here the stoichiometric coefficient for K2SO4 was only 1. And water, it is a non-electrolyte. Right, I will explain about water, and you don't write water as H plus and OH minus, because you should remember one important thing, that always insoluble and non-electrolytic substance should be written in formula unit form. In this equation, we have water which is non-electrolyte. It shouldn't write as H plus and OH minus. It has to be written as H2O only. So I'm not considering to convert it into ionic form, that water. So after doing this, what to do? We have to identify the spectator ions. First, what is meant by spectator ions? Spectator ion. It is very simple. Those ions which do not take part in the reaction are known as spectator ions. Those ions which do not take part in the reaction are known as spectator ions. Let me take at reactant side, does SO4 minus 2 involving in the equation, in the reaction? No. So it can be a spectator. Does K plus is involving in equation? No. So it could be a spectator ion at reactant side. And here also we have SO4 minus 2. At product side, we have SO4 minus 2 spectator ions and K plus. Right. By removing spectator ions and by adding them, we can get the net ionic equation form. Let me write first at reactant side what I can write. 10 Fe plus 2. And I need not to write 10 SO4 minus 2 because it is spectator ion, so that I can remove it. Next, I need not to write 2 K plus because here K plus is a spectator, that should be removed. 2 MnO4 minus and 8 into 2, 16 H plus. Again, I am not writing SO4 minus 2 as it is spectator ion. Now, reactant side done. We should go for product side. At product side, we have 10 Fe plus 3 and 15 SO4 minus shouldn't write. And we have to write 2 Mn plus 2 and 2 SO4 minus 2 shouldn't write. And K plus shouldn't write. SO4 minus 2 shouldn't write. And we have to write 8 H2O as it is because it is a non-electrolyte. Non-electrolyte always has to be written in formula unit form only, not in an ionic form. Now we have got an ionic equation. That's simple, how to convert a formula unit equation into an ionic equation form. Understood? And from this, if you want to convert it into a formula unit form, add spectator ions, whatever you have removed. So then you will get 10 moles of FeSO4 plus 2 moles of KMnO4 and 8 moles of H2SO4, then 5 moles of Fe2SO4 taken twice, and 2 moles of MnSO4 and 8 moles of H2O. This is how you can convert an ionic equation form into a formula equation form. Okay, let us move on to the today's topic, balancing of redox reaction. The basic principle to balance the redox reaction is that the total increase in oxidation number must equal the total decrease in oxidation numbers. And one more important thing you should remember, that all balanced equations must satisfy 2 criteria. They are mass balance, that is, there should be the same number of atoms of each kind in reactants and products. And another one is charge balance, that is, the sum of the actual charges on both sides of the equation must be equal each other. Here we go with first method, the oxidation number change method to balance the redox reaction. What is the method? Oxidation number change method. Oxidation number change method. This method is based on the fact that in a balanced redox reaction, the total increase in oxidation number is equal to the total decrease in oxidation number. And here, let me take an example to explain the rules associated with this method and how to balance a redox reaction by using this method. So let me take an example in acidic medium. The example is here Fe plus 2 plus MnO4 minus gives rise to Fe plus 3 and Mn plus 2. It is in acidic medium. So here we have to balance this redox reaction by using oxidation number method. So let me explain one by one step. Listen carefully. It is very important and very simple method also. So first, rule number 1 is that you just identify the elements that changes their oxidation states. That means I can identify here iron is changing its oxidation number from plus 2 to plus 3. And I can identify another element, that is manganese, whose oxidation number is going to change from plus 7 to plus 2. After identifying the elements undergoing oxidation and reduction, you just write the oxidation number of those elements only. So here for iron already it is given plus 2. For manganese we have to write plus 7. For iron at product side plus 3. For manganese at product side plus 2. Already it was there. This is rule number 1 we have to write. And rule number 2, we have to balance only those atoms of elements changing their oxidation numbers. Like we have to balance iron and manganese. Very simply, we can say that we should balance iron and manganese. Right. So let me check at reactant side how many iron atoms we have. Only 1. And at product side 1. Hence they get balanced. At product side 1 Mn, at reactant side 1 Mn. So they got balanced. Here no need to multiply with any coefficient. Got it? Now rule number 3. So we have to draw a bracket for the oxidation process. And same as for the reduction process. For example, the oxidation is what? Fe plus 2 to Fe plus 3. It is oxidation. And the reduction is Mn plus 7 to plus 2. This is reduction. Now we have to write during the oxidation, the element increases its oxidation number by how much factor? That is plus 2 to plus 3 means it is just increases by 1 unit. Plus 7 to plus 2 means it decreases by 5 units. That is rule number 3 done. Now rule 4 is that we have to insert coefficient to balance the total increase in oxidation number with total decrease in oxidation number. For that, we need to do cross multiplication. That is, 1 should be multiplied with the reduction equation and 5 should be multiplied with oxidation equation. If you do in that way, we will get 5 moles of Fe plus 2 and 1 mole of MnO4 minus gives rise to 5 moles of Fe plus 3 and 1 mole of Mn plus 2. So this is rule 4. And rule 5, very important, right? Except hydrogen and oxygen, we should balance all other atoms by just doing inspection. Let me inspect. Except oxygen and hydrogen, remaining all atoms has to be balanced. Here we have 5 iron atoms. At product side also we have 5 iron atoms. At reactant side we have 1 manganese. At product side also we have 1 manganese. So that except oxygen and hydrogen, everything is balanced. Now rule 6 is very, very important. That is to balance hydrogen and oxygen. To balance hydrogen and oxygen atoms. It is very simple also. So here we have 2 cases. If the reaction is given in acidic medium, like our example, in acidic medium, for 1 excess of oxygen, add 1 H2O on the opposite side and add 2 H plus ions on the same side. If it is in basic medium or alkali medium, in alkali or basic medium, right? For 1 excess of oxygen atom, add 1 water molecule on the same side and 2 OH minus ions on the other side. In case hydrogen atoms are still unbalanced, for 1 excess hydrogen atom, add 1 OH minus on the same side and 1 water on the other side. Right. In some cases, both hydrogen and oxygen atoms are balanced together by adding water only. So let me take this example. In this, it is taking place in acidic medium. So at reactant side, we have 4 oxygen atoms. At product side, we don't have any oxygen atom. So what we have to do, as it is taking place in acidic medium, we have 4 excess of oxygen at reactant side. To balance them, we need to add 4 water molecules at product side and 8 H plus ions on the same side. So now the net balanced equation is 5 Fe plus 2 and MnO4 minus 8 H plus gives rise to 5 Fe plus 3 and Mn plus 2 and 4 H2O. So this is balanced equation. If you want to cross check whether your balanced equation is correct or not, you just do one thing. You take the net charge on the reactant side. Here we have 5 into plus 2 plus minus 1 and plus 8. So what could be the net charge? Plus 17. And you check it on product side. Here plus 15 and plus 2, which is equal to plus 17. So charge get balanced and each kind of atom get balanced. So it is our balanced net equation with respect to charge and with respect to atoms, not with respect to mass. Got it? It is our final balanced equation with respect to charge and as well as with respect to atoms. So let us do one more example in basic medium. So that was the example in acidic medium. Now we should do one more example in basic medium. So here I am taking the equation I2 iodine is converting into I minus and IO3 minus in basic medium or alkali medium. So what is our first rule? We have to identify the elements undergoing oxidation and reduction. Here, what is the oxidation state? 0, -1 and 0, +5. 0 to -1 is reduction and 0 to +5 is oxidation. Reduction by how many units? 1 unit. So to make it simple, better to write the equation like this. I2, and I am taking I -1 and IO3 minus. So here first we have to write the oxidation states. No, 0, 0, -1, +5. Then we have to balance only those atoms who are undergoing oxidation and as well as reduction. So at reactant side we have 4 iodine, but at product side we have only 2 iodine atoms. To make them 4, I am multiplying with 2 and 2. Now all the atoms undergoing oxidation number change get balanced. Now we need to identify the oxidation and reduction reactions separately, and we should indicate them with a bracket. So 0 to -1, it is reduction by 1 unit. As we have taken in one molecule of I2, there are 2 iodine atoms, so into 2, which is equal to 2 units. And 0 to +5 increases by 5 units, as we have 2 iodine atoms in each molecule of iodine. So we should take 5 into 2. We can cancel these coefficients. Simplest whole number ratio has to be taken. Now, to make them equal means the increase in oxidation number, the decrease in oxidation number. To make them equal, we should insert coefficients or not. So here the coefficient should be 5i2 plus 1i2 gives rise to 10i minus and 2IO3 minus. Right. Now let us check rule number 5. Let us inspect except oxygen and hydrogen, rest of the elements balanced or not. At reactant side we have 12 iodine atoms, at product side also 12. So they got balanced. Now we need to balance oxygen as it is in basic medium. For each oxygen, for each excess of oxygen, we should add 1 water on the same side and 2 OH minus ion opposite side. So here we have 6 oxygen atoms. So I should add 6 water molecules. And here 12 OH minus, so that it get balanced. So what is the final balanced equation? 5i2 plus I2. I can write it as 6i2 and 12 OH minus gives rise to 10I minus and 2IO3 and 6H2O. This is balanced equation. And if you want to cross check your answer, you just do charge balancing. Here I have -12 at reactant side and -12 at product side. So they got balanced. This is how we can do balancing of a redox reaction by using this one. And apart from this, we can easily use some tricks to do this. So in the next video, we'll discuss more working examples on this redox reaction balancing. Right. So please stay tuned to SHLOKA'S Academy YouTube channel. And you can also download the app SHLOKA'S Academy from the Play Store, where you can get more study material and more assignments, more daily practice questions, all these things. Thank you.